All right, we're getting started with GitLab Application Security testing, and we're on the dependency scanning part of the videos. This video is me reading through our dependency scanning article. It's a little bit academic, so if you're not into reading articles over video and want to read it faster than I can read it, you can go read it on your own. I'll show you where it is. If you want to see hands-on, go to the previous video and see where I actually did the hands-on tutorial that's also linked to in our docs. All right, we're getting started with GitLab Application Security testing, and we are on the dependency scanning stage. Right here, I'm going to hold down the Option key and click on Dependency Scanning to open in a new tab. The previous video, we did the tutorial. It's much more exciting. Go watch that video. Dependency scanning. I'm going to go ahead and hit the Command plus key because I like to read big text. Dependency scanning. Available for Ultimate on all offerings, meaning both our GitLab.com software as a service and your own self-managed install. So this is a Ultimate level, so it's a paid offering. Dependency scanning analyzes your application's dependencies for known vulnerabilities. All dependencies are scanned, including transitive dependencies, also known as nested dependencies. Dependency scanning is often considered part of software composition analysis, or SCA. SCA can contain aspects of inspecting the items your code uses. These items typically include application and system dependencies that are almost always imported from external sources, third-party libraries, rather than sourced from items that you wrote yourself. Dependency scanning can run in the development phase of your application's lifecycle. Every time a pipeline runs, the risk to your application before the code change is committed. As I mentioned on the previous tutorial video, as an aside, GitLab's approach to making your mainline or production line application risk posture more secure with every feature branch commit is to first run a scan on your mainline branch and show you the vulnerabilities like we did in the first step of the tutorial in the previous video. But then every feature branch you create from your mainline branch is also scanned and has a vulnerability report shown on a merge request. That allows a developer to fix old, crusty dependency packages that need updating before it ever sees your mainline branch. The developer fixes dependencies that are out of date and insecure, and once it passes a security finding, the developer can then merge that back into your mainline branch. The net effect of this is that your mainline branch's security or risk posture always moves forward and never backwards. Every commit, you get either maintain the security level you're at, or you've updated packages and actually make your security posture better. GitLab offers both dependency scanning and container scanning to ensure coverage for all those dependency types. To cover as much of your risk area as possible, we encourage you to use all of our security scanners. For a comparison of these features, see dependency scanning compared to container scanning. Here's a little screenshot of what dependency scanning is. So this application, dependency scanning, detected 10 new critical and 22 new high severity vulnerabilities out of 72. And then it lists the last few. There's even a little video that gives you an overview of dependency scanning. Feel free to watch that at your leisure. Requirements. Dependency scanning runs in the test stage, which is available by default. If you redefine the stages in your GitLab.ci YAML file, then the test stage is required. The only reason that this document has to say that is because if you have a highly customized GitLab pipeline file, that's the .gitlab-ci.yaml file, and for some reason you have removed the test stage from your YAML file, then this isn't going to work. So you have to have at least the test stage defined. Let me show you what that looks like in the previous tutorial project. If I head back over in my previous tutorial project to code repository and I go look at my GitLab CI YAML file, this stage under stages : test, that has to exist. That's all they're saying with that text. heading back over here to our academic paper here on this. To run dependency scanning jobs by default, you need a GitLab runner with the Docker or Kubernetes executor. If you are using shared runners on GitLab.com, this is enabled by default. And that's why in the previous video, I simply used GitLab.com to do the tutorial, because I didn't have to worry about runners and I didn't have to worry about any kind of Docker, Kubernetes, or anything else. The analyzer images provided are for the Linux AMD 64 architecture. Dependency scanning does not support runtime installations of compilers and interpreters. We have other scanning security features for that. Supported languages and package managers. As a solutions architect, I receive a lot of questions about, is this language or this language supported? This document tells you whether or not they are. If you're a .NET developer, all versions of .NET using NuGet as a package manager, we look at the packages.lock.json file, and yes, we support and can process multiple files. Same with C#. For C and C++, all versions of C and C++ are supported if you're using the Conan package manager, and we look at the conan.lock file, and we can process multiple files, also supported. If you're a Go developer, all versions of Go are supported using the native built-in Go package manager, where we look at go.mod and go.sum, and we can process multiple files. If you are a Java and Kotlin developer, specifically not Android phone developer, but Java and Kotlin application developer, and you're running Java 8 long-term support, 11 long-term support, 17 long-term support, or 21EA, which I don't even know what 21EA is, you're using either Gradle or Maven as your package manager. We look at the build.gradle.kts file. If you're using Maven, we look at, of course, the pom.xml file, and we will look at whichever of those files is in the root or the lowest level nested directory. So you have multiple Java projects in a single GitLab or project or repository, then our scanner will look at the Java project and package manager file that is at the lowest level. We'll see that note here in just a moment here. In fact, there's a little number 3 that'll tell us about that. Let's go down and look at the number 3 real quick. Gradle is not supported with FIPS mode is enabled, so you have to know that. Java 21EA is only available when using Maven and is not supported with FIPS mode. And then support for Kotlin projects and Android is tackled on one of the issues here. So we are presently working on supporting Kotlin and Android type application support. PHP. All versions of PHP are supported as long as you're using the Composer package manager. We look at the composer.lock file and we can process multiple PHP projects and files. Python, big call out here. You need to be running a modern version of Python for our dependency scanners to pick up dependency problems. So that would be Python 3.9 and 3.10. If you're using the setup tools, we will look at your setup.py file. If you're using pip, which I think everybody under the sun is, we will look at your requirements.txt, your requirements.pip, and your requires.txt files to look for dependency issues. We will probably look for just a single one of these at the lowest nested directory level in your project. Again, if you have multiple Python projects, consider splitting those out into separate GitLab projects, also known as repositories, or at least know that we will only scan like the root of these particular projects. In Python 3.9 and 3.10, we also support pipenv, the pip environment. So we'll look at the pip file and pip.lock. We also support poetry, so we'll look at your poetry.lock file to figure out if you've included some vulnerable dependencies. In Ruby, we support all versions of Ruby as long as you're using Bundler. Bundler has a gemfile.lock, and we'll look at your gems.locked file, and we'll process multiples of those files to make sure that we get all the dependencies that you've added with Bundler. If you're a Scala developer, we support all versions of Scala, as long as you're using the SBT package manager, which is a very popular one, and we will look at your build.spt file. We'll find the first one that we can find, which is why we don't process multiple files. Typically a single Scala project will have a single build file, and we'll look at that file for dependencies. I'll let you read through all of the gotchas here. Specifically around number 5, support a Python 3.10, add the following standa to your GitLab pipeline or CI/CD configuration file. This specifies Python 3.10 images to be used instead of the default 3.9. So we have clearly a different security scanner that scans Python 3.9 versus Python 3.10. Support for poetry projects. So the poetry.lock file is added in way back in GitLab 15.0. Support for projects without poetry.lock file is tracked in one of our issues. So as long as you have the poetry.lock file, we can do dependency scanning for you. And support for SPT for Scala developers 1.3 and above was added way back in GitLab 13.9. Dependency detection. Dependency scanning automatically detects languages used in the repository. All analyzers matching the detected languages are run. That's a lot of words to say. GitLab automatically detects what language is in a particular GitLab project or repository and runs the appropriate scanner for that language. There is usually no need to customize the selection of analyzers. We recommend not specifying the analyzer, so you automatically use the full selection for best coverage, avoiding the need to make adjustments when there are dependencies or removals. However, you can override the selection using the variable dx_exclude_analyzers. The language detection relies on CI job rules and searches a maximum of 2 directory levels from the repository's root. For example, the Gymnasium dependency scanning job is enabled if a repository contains either gem file, API gem file, or API client gem file, but not if the only supported dependency is API v1 and client gem file. So, for those of you who have repositories that have this nested file structure, consider setting up a separate GitLab project for your API, or collapse the API v1 stuff so that your client gem file gets scanned as part of the 2 directory levels. For Java and Python, when a supported directory file is detected, dependency scanning attempts to build the project and execute some Java or Python commands to get the list of dependencies. For all other projects, the lock file is parsed to obtain the list of dependencies without needing to build the project first. So that's just a nice way of saying is if you have a large Java or Python application, we're going to probably run whatever package manager you have and have the package manager spit out a list of dependencies so we have a true and real list of dependencies. That might take a little bit longer than just reading a text file. So that's a nice way of saying that might take a few seconds longer to run that job than just looking at a text file and detecting a list of out-of-date versions of stuff. When a supported dependency file is detected, all dependencies, including transitive dependencies, are analyzed. What the heck is a transitive dependency? You ask. I asked. What is a transitive dependency in Python? Transitive dependencies are indirect dependencies, otherwise known as dependencies of dependencies. Yes, we scan for that, and we detect them. For example, if package A has a dependency B, and dependency B has dependency C, then package A has a transitive dependency on dependency C. I get asked every once in a while, what if I include something that has a dependency? We scan for dependency of dependencies, and that's called transitive dependencies. All right, there is no limit into the depth of nested or transitive dependencies that are analyzed. So we scan dependencies of dependencies. We also scan dependencies of dependencies. We also scan dependencies of dependencies of dependencies ad nauseum. Dependency analyzers. Dependency scanning supports the following official analyzers: Gymnasium Maven, Gymnasium Python. Each of these supported Gymnasium-based dependency scanning analyzers exists in the following project: Gymnasium. You can click there and read more about the open source project. These analyzers are published as Docker images, which dependency scanning uses to launch dedicated containers for each analysis. You can also integrate a custom security scanner. For those enterprise customers who already have a Sonar Cube or Fortify or some other third-party scanner, you can integrate that in with your GitLab pipeline, and we will support the integration of the results from those scanners in with your pipeline. Click that link right there, the security scanner link, to learn more about how to do custom integrations. How analyzers obtain dependency information. GitLab analyzers obtain dependency information using one of the following two methods. Parsing a lock file directly, which we prefer because parsing a text file and looking for versions is a lot faster than compiling an application. Running a package manager or build tool to generate a dependency information file, which is then parsed. So that's probably the second thing we would do because it takes slightly more time, a few more seconds to do that. The following package managers use lock files that GitLab analyzers are capable of parsing directly. So go down here and find your favorite language. There's some gotchas here. Dependency scanning for Go projects. It only parses the go.sum file if it's unable to generate the build list used by the Go project. If you're a NuGet person or a NuGet person, so NuGet versions 1 and 2 are parsed. We've tested it on NuGet version 4.9. Support for NuGet version 2 lock files was introduced in GitLab 16.2. Let's take a look here at number 3 for NPM. For our Node friends, NPM version 1, 2, and 3 are supported. We've tested on the package managers version 6, 7, and 9. Let's see here. Support for lock file version 3 was introduced in GitLab 15.7. Let's see, number 4 for Yarn people, the good old Yarn JavaScript and NPM. Versions 1, 2, and 3 are supported, and of course we've tested on 1, 2, and 3. Support for your Yarn version 2 and 3 was introduced in GitLab 15.11. However, this feature is also available in versions of GitLab of 15.0 and later. So we've introduced it, but it's available if you're running an older version of GitLab as long as it's 15.0 and later. The following features are not supported for Yarn versions 2 and 3, workspaces, and Yarn patch. So if you use those commands, those are not supported. Yarn files that contain patch, a workspace, or both are still processed, but these features are ignored. For those of you who are not developers, Yarn workspace and Yarn patch files are just ways outside of a normal software, like a normal Git-based software development process that a developer can go quickly test something to see if a patch will fix or another third-party library will fix something very quickly. Those workspaces often are not committed to a Git repository, and so we wouldn't be able to scan those anyway. So hopefully no surprises there, but if you use Yarn patch or Yarn workspaces, we're not going to be able to scan those files. You got to include that in as part of your project. Obtaining dependency information by running a package manager to generate a parsable file. To support the following package managers, GitLab analyzers proceed in 2 steps. 1, we execute the package manager or a specific task to export the dependency information. Takes a few extra seconds, is a little bit slower. Then we parse the exported dependency information. That's probably a text file. It's probably easy for us to parse. Here's your favorite package manager. There's SPT. We installed 1.6.1 of that, and we've tested it on 1.6.1 along with a series of older versions. If you're a Java Maven or Java Gradle person, Maven, we've pre-installed Maven version 3.6.3, and we've tested on Maven 3.6.3. If you're a Java Gradle person, we've pre-installed on our scanner 3.3. We have tested on 7.3, 6.9, 6.7, 5.6.4. I have no idea what language Setup Tools uses. Nope, that's Python. If you're using Setup Tools as your package manager, we have pre-installed version 58.1.0 to export your list of dependencies, and we have tested on slightly newer versions, 65.6.3 of Setup Tools. So basically, these pre-installed versions is just telling us what version of the package manager is used by our automated pipeline process to export the list of dependencies. So there's no surprises, right? For pip environment, we have pre-installed 2022.1.8. We have tested on that version along with It looks like we've tested on that version, and there's a little note number 3 to read. So let's go read number 3. This test confirms that if pipfile.lock file is found, it is used by Gymnasium to scan the exact package versions listed in the file. Again, we have a bias towards scanning a text file because the key value pair in a text file is way easier to scan, compare against a database of known vulnerabilities, and tell you if you have an out-of-date, crusty old version of some third-party library. If you're a Go developer, we pre-package Go version 1.18 and have tested on Go version 1.18 and use that version to export a list of your dependencies and then scan that. So hopefully no surprises there. Number 4, because the implementation of Go build, the Go build process requires network access, a preloaded mod cache, so the command go mod download, or vendor dependencies. For more information, refer to the Go documentation on compiling packages and dependencies. Go click that if you're a Go developer. How analyzers are triggered. GitLab relies on rules exists. That's a keyword you can use in your GitLab pipeline file to start the relevant analyzers for languages detected by the presence of the supported files in the repository as shown in the table above. So that's a fancy way of saying that if we recognize package.lock, a yarn.lock, if we recognize the name of the file, the scanner will automatically assume it's a yarn.lock file and go ahead and scan it and apply the particular dependency scans to that file. You would expect that. The current detection logic limits the maximum search depth to 2 levels. For example, the Gymnasium dependency scanning job is enabled if a repository is, again, in the gemfile.lock file, is in a directory called ABI gemfile.lock or API client gemfile.lock. But our scanner, if you nest your gemfile.lock past 2 directory levels deep, it will not be scanned. So it is not if the only supported dependency file is hiding out, let's say, 1, 2, 3 levels deep in a path like API v1 client gemfile lock. Again, you might want to consider either collapsing that directory structure to make it look more like API gemfile lock, API client gemfile lock, or what some of my customers do is they simply create a separate GitLab project, or also known as a repository, to host this and then collapse the directory structure in that separate GitLab project. When a supported dependency file is detected, all dependencies, including transitive dependencies, are analyzed. We already talked about what transitive dependencies are. They're dependencies of dependencies. There's no limit to the depth of nested or transitive dependencies are analyzed. I feel like we were repeating ourselves here. Is there an echo in the room? How multiple files are processed. If you run into problems with scanning multiple files, contribute to the comment on this issue. And the reason we ask for you, the community's help on something like this is because there's a lot of different languages, and so it's easy if we have nested multiple dependency files, requirements.txt, that are scattered all over inside of a project, and we miss one of them, then it sure would be nice to be able to cover that in a future version of our GitLab dependency scanner. So please contribute to that issue and tell us if we missed something. In Python, we only execute one installation in the directory where either a requirements file or a lock file has been detected. And that's pretty typical for most Python projects. Dependencies are only analyzed by Gymnasium Python for the first file that is detected. Again, most Python projects probably have a single requirements.txt file that lists the dependencies. Files are searched in the following order: requirements.txt first, requirements.pip, or requires.txt for projects using pipfile lock, for projects using pip environment, poetry.lock for projects using poetry, setup.py for projects in Python using setup tools. The search begins with the root directory and then continues with subdirectories if no builds are found in the root directory. Consequently, a poetry lock file in the root directory would be detected before a pip environment file in a sub. So if you're using multiple package managers, multiple ways to manage your single Python project, just keep in mind that we're going to pick up a particular set of dependencies for our scanner, and once we find that one file, that is the list we're going to use. Java and Scala. We only execute one build in the directory where the build file has been detected. For large projects that include multiple Gradle, Maven, or SBT builds, or any combination of these, Gymnasium Maven only analyzes dependencies for the first build of the file that is detected. Now, this sort of architectural pattern happens a lot in big, large monolithic applications that are long-lived, so legacy applications, where you have multiple different builds contained within the same GitLab project, also known as a repository. May I suggest that if you have a large monolithic application that you've broken apart but still in the same code project or repository, think about creating separate code projects or repositories so that those logical spots where you've broken apart your Java application or Scala application can be scanned as separate GitLab projects or repositories. And then it also means that you can manage the security dependencies separately, because if there's been a logical separation in your monolithic application, that's also a good way to logically separate the management of dependencies that you have for those logically separate applications. Build files are searched for in the following order. First, pom.xml for a single or multi-module Maven project. Then we look for the build Gradle KTS for single or multi-project Gradle builds. And finally, build SPT for single or multi-project SPT, Scala builds. The search begins with the root directory and then continues subdirectories if no builds are found in the root directory. Consequently, an SPT build and file in the root directory will be detected before Gradle build in a subdirectory. So again, if you have a large monolithic application that has a Scala build and a Java build contained in the same GitLab project or code repository, you might want to think about separating those into separate projects or separate code repositories so that they can have their dependencies scanned independently. JavaScript. The following analyzers are executed, each of which have different behavior when processing multiple files. Gymnasium supports multiple lock files. Retire.js does not support multiple lock files. When multiple lock files exist, retire.js analyzes the first lock file discovered while traversing the directory tree in alphabetical order. From GitLab 14.8, the Gymnasium analyzer scans supported JavaScript projects for vendor libraries, that is, those checked into the project but not managed by the package manager. Let's dig into that for just a second. So we'll actually detect and scan vendor libraries. So like a vendor gives you a binary file, and we'll ask for the version of that binary so that we can scan it and figure out if that binary might be vulnerable or a dependency that's problematic. For Go, multiple files are supported. When a go.mod file is detected, the analyzer attempts to generate a build list using the minimal version selection. If a non-fatal error is encountered, the analyzer falls back to parsing the available go.sum file. The process is repeated for every detected go.mod and go.sum file. For Go, we clearly try to use the Go version that we talked about before to create a build list, and then the minimum version selection from that list to figure out what you're actually using for dependencies in your Go application. If for some reason the version of Go cannot produce that, we'll fall back on the text file that lists your Go dependencies. For PHP, C++, .NET, C#, Ruby, and JavaScript, the analyzers for these languages supports multiple lock files. Support for additional languages. Support for additional languages. Dependency managers and dependency files are tracked in the following issues. Poetry, Python, which supports the pyproject.toml file using Gymnasium, is presently being tracked in GitLab issue number 32774. Contribute your scanner. The security scanner integration documentation explains how to integrate other security scanners into GitLab. In fact, if you have an open source security scanner that GitLab presently isn't using for a language that we don't presently scan or support for dependencies, we would love to have you contribute and give back to the open core part of our product by integrating that open source scanner into GitLab's open source core. Check out that issue to do that. Configuration to enable dependency scanning for GitLab 11.9 and later. That was a long time ago. You must include the dependency scanning GitLab CI YAML template that is provided as a part of your GitLab installation. For GitLab versions earlier, 11.19, you can copy and use the job as defined in that template. Simply add the following to your GitLab CI YAML file, include dependency scanning. In an earlier video, we explained how you could just go clickety-clack and through a merge request in settings in your particular project, just use the web interface and it would automatically add that included template file for you, so you'd never have to do any kind of coding at all. You can just simply add that as part of your settings of your project. The included template creates dependency scanning jobs in your CI/CD pipeline and scans your project source code for possible vulnerabilities. The results are saved as a dependency scanning report artifact that you can later download and analyze. Due to implementation limitations, we always take the latest dependency scanning artifact available. We have to call that out right there. I have a number of customers who ask for, I wanted to see what did my dependency vulnerability report look like 6 months ago? And unfortunately, due to the implementation limitations, we can't tell you that. The vulnerability report just shows you where you currently are as far as your vulnerability posture. Now, intermediate and advanced users of Git will know that you could easily use the native Git and the Git log and Git history to check out an older commit, say from 6 months ago, use that commit and create a new feature branch and have GitLab's automatic scanner scan that feature branch and generate a vulnerability report from that. So that might be one way for customers who want to know, what did my vulnerability report look like 6 months ago? You could use the revision control system Git to check out an old commit, make a feature branch from that, and allow the GitLab scanner to run to see what the vulnerability report looked like a long time ago. Enable dependency scanning via automatic merge request. All right, as I hinted at, to enable dependency scanning in a project, you can create a merge request. On the left sidebar, you search and go to and find your project. We select security configuration. I happen to have a project up here from the previous video, so I'm going to go down to the little shield here under secure, and I'm going to select security configuration. What's the next thing I do? In the dependency scanning row, select configure with a merge request. So I'm going to find dependency scanning. And of course, because it's already part of my pipeline in this project from the previous video, it's already been added to my GitLab-ci.yaml pipeline file. However, if it was not enabled, just like all of these other things, I would just simply click enable dependency scanning right there, and it would create a merge request where I could click merge, and it would automatically, no code needed, no text editor needed, it would automatically enable dependency scanning in my GitLab pipeline file for me. Review the merge request and merge it. Pipelines are now included with the dependency scanning job. All right, customizing the dependency scanning settings. The dependency scanning settings can be changed through CI/CD variables, as you might suspect, by using the variables parameter in the GitLab CI YAML. So after we've included the template file for dependency scanning, we could then add another section called variables. And again, this is nothing more than a key value pair. So here's the key of secure log level, and I want to output in my job at the error level of logging. Because the template is evaluated before the pipeline configuration, the last mention of the variable takes precedence. So if you have a whole lot of variables in your pipeline file, the last key value pair is the one that gets run as part of the job, which again, we would expect for most other programming languages to treat key value pair assignments in that fashion. Overriding dependency scanning jobs. To override job definition, for example, to change properties like variables or dependencies, declare a new job with the same name as the one to override. place this new job after the template inclusion and specify any additional keys under it. For example, this disables the DS remediate for the gymnasium analyzer. So here we've already included the template file to enable dependency scanning, so we can ignore that. And then we tell the gymnasium dependency scanning to turn off the DS remediate by setting it to false. So in this way, you can go look up all the different things you can do to gymnasium dependency scanning, and through variables at the time that your GitLab pipeline runs, tell Gymnasium to do or not to do various things. This is a way, of course, that customers can tweak and customize the built-in GitLab dependency scanners. To override the dependencies attribute, add an override job as above, targeting this attribute. For example, Gymnasium dependency scanning, dependencies build. Available CI/CD variables. Here we're going to get really nerdy and really specific about everything we can do to throw at and customize the GitLab dependency scanner. Dependency scanning can be configured using the environment variables. All customization of GitLab security scanning tools should be tested in a merge request before merging these changes to the default branch. Failure to do so can give unexpected results, including a large number of false positives. That callout's important because the way that the GitLab dependency scanner works is the first time that you scan your mainline branch, when you first enable dependency scanning in your GitLab pipeline, a baseline security risk posture is evaluated and created. By no surprise, the documentation instructs us to create a feature branch and then play with these CI/CD variables over on our feature branch. That way, the baseline of our mainline or default branch is not changed or mucked with, and we still can maintain that baseline and know what risk or security posture our mainline branch is at. All right, so that's the warning. Configuring dependency scanning. The following variables allow for configuration of global dependency scanning options, scanning settings. Additional CA cert bundle. Bundle of CA certs to trust. Super important in enterprise if you have behind a firewall or a local corporate network or something like that, where you may not have public certificate authorities and you want to trust, say, the company's Active Directory certificate, and you want to make sure that gets bundled in as part of the dependency scanner so it knows to trust sources that the CA has signed. The bundle of certificates provided here is also used by other tools during the scanning process, such as Git, Yarn, and npm. See the Using Custom SSL Certificate Authority for more details. DS excluded analyzers. Specify the analyzers by name to exclude from dependency scanning. For more information, see Dependency Scanning Analyzers. Feel free to click that link. DS excluded paths. Dependency scanning excluded paths. Exclude files and directories from the scan based on their paths. A comma-separated list of patterns. Patterns can be globs. See that on how to write a glob for supported patterns. Or file or folder patterns such as doc, spec. It's very often that if you have a GitLab pages enabled, like a wiki site enabled as part of your code project or repository, that you'll want to not bother scanning the wiki site or the documentation pages associated with that project. So you might want to actually do a DS excluded paths and exclude the pages or the doc or the spec from being scanned. A lot of times over time, documentation gets rather bloated, and there's an awful lot of documentation, and so there's no point in scanning documentation because it's not actual code that's going to change your dependency posture at all. So you might as well exclude that from being scanned. The dependency scanner image suffix. Suffix added to an image name. Introduced in GitLab 14.10, GitLab team members can view more information on this confidential issue. Automatically set to FIPS when the FIPS mode is enabled. No idea, probably to add a specific suffix to an image name, probably in a controlled environment where you're creating images. with a third-party tool, I would imagine, that is managing your images, and that artifact repository is separate from GitLab for some sort of a compliance or auditing or some other purpose. Again, probably like a government customer would probably end up doing something along those lines. So here we can specify the suffix added to an image name so that some third-party thing can archive and produce auditability for the images produced on every single feature branch and every single mainline branch. All right, dependency scanning max depth defines how many directory levels deep that an analyzer should search for supported files to scan. A value of -1 scans all directory regardless of depth. Default is 2. So that's an interesting, that's an interesting variable that we can run. In other parts of the documentation, we said that we had a max depth of 2, and you can see here the default is 2. But this clearly allows us to override that and scan everything under the sun, which probably will take more time to scan. But if I have a JavaScript application that maybe is legacy and has multiple different parts of the Java application in different subdirectories, which is a common pattern that was used in the last 30 years to develop Java applications, perhaps I want to scan the dependencies from all of those applications. The official doc earlier said that we're only going to find one and scan one, and I suggested that you break logical separate applications into separate GitLab projects, also known as repositories. But here, you can change the max depth scan, make the scan take longer, and have it search nested directories further than 2. Secure Analyzer's prefix. Override the name of the Docker registry, providing the official Docker images. Exciting in enterprise situations where your enterprise has walled off access to the internet and has its own Docker registry that they want to use internally on an internal network. So there's how you can override the name of the Docker registry, providing the default images, and or specify some sort of a proxy out to the public internet. Configuring specific analyzers used by dependency scanning. The following variables are used for configuring specific analyzers used for specific language framework. All right, the Gymnasium DB local path from the Gymnasium analyzer defaults to looking at the root directory Gymnasium DB, which is the path to the local Gymnasium database. You can override these things if you so choose. Gymnasium DB updates disabled. You can disable updating the database. So if you baselined a particular version of an application at a given time and you don't want the database to be updated, you can specify a variable here and make that false to disable automatic updates for the Gymnasium DB advisory database. For usage, see some of the examples right there in that link. There is a Gymnasium database remote URL. So if you want to host your database on a separate place, perhaps you want to perhaps you have a large enterprise and you're running scanning for Gymnasium style scanning for hundreds, thousands of projects. Maybe you want to host your own Gymnasium database that you only go and fetch once a day. You could specify a separate spot or a separate repository where it goes and gets fetched during the nighttime, and then everybody uses the hundreds or thousands of runs of your pipeline, use that one Gymnasium database for finding vulnerable dependencies. So that might be a scaling thing like on an internal corporate network. Gymnasium DB ref name. By default, the Gymnasium analyzer uses the master branch for the remote repository database. Again, that's if you hosted it on a separate or remote GitLab project or repository. DS remediate. True, false in FIPS mode. Enable automatic remediation of vulnerability dependencies not supported in FIPS mode. DS remediate timeout. 5 minutes. Timeout for auto remediation. Gymnasium library scan enabled. By default is true, enabling detecting vulnerabilities in vendor JavaScript libraries. So if you have a vendor JavaScript library you know is vulnerable or don't want it scanned, you can set that to false. For now, Gymnasium leverages the retire.js to do this job, introduced in GitLab 14.8. DS or dependency scanning Java version. What version of Java should Gymnasium Maven use? By default, we default to 17. But maybe you're developing legacy applications in Java 11, or maybe you're developing Java applications in Java 21. You can specify 8, 11, 17, or 21 versions of Java. for the dependency scanner to run. Maven CLI ops. So this would be the Java Maven package manager command line options. So you can tell it to skip certain tests. You can run in batch mode, lists of command line arguments that are given and passed to Maven by the analyzer. See an example for using private repositories. So if you have, again, like a legacy application or something very specific when you're running your Maven tests that cause them to fail, you can actually specify this Maven CLI ops variable and then give it in double quotes whatever list of command line stuff that you want to skip. Gradle CLI options, same idea. List of command line arguments that are passed to Gradle by the analyzer. And analyzation time. SBT CLI ops, same idea. List of command line arguments that the analyzer passes to your Scala SBT manager. Pip index URL defaults to the pypy.org simple, so the base URL of the Python package index. Pip extra index URL, so if you have extra places other than pypy that you want to check, an array of extra URLs of package indexes in addition to the pip index URL, comma separated. Warning, read the following security consideration when using this environmental variable. If you have stuff that you've included in your Python projects that is not hosted or outside of pypy, you might want to include those package indexes from those other third-party places. Pip requirements file. Pip requirements file to be scanned. If you want to override the default that it finds, you can force it to scan a specific pip requirements file. Pip environment, pypy mirror. If set, overrides the pypy index used by the pip environment with a mirror instead. Useful in a large enterprise that may have hundreds or thousands of projects doing dependency scanning that would normally go out and hit the pypy site and potentially hit too much traffic against pypy. Perhaps you want to use the mirror, or up above you can, of course, configure up a proxy. Pip version. So dependency scanning pip version. You can override the pip version that is used by forcing install of a specific pip version. For example, 19.3 in double quotes. Otherwise, the pip install in the Docker image is used. And that was introduced way back in GitLab 12.7. Dependency scanning pip dependency path. Path to load the Python pip dependencies from. Your dependency scanning include dev dependencies. By default is set to true, but when you override it and set it to false, development dependencies and their vulnerabilities are not reported. Only Composer, NPM, and Poetry projects are supported and introduced in GitLab 15.1. So this won't surprise you, we default to scanning development dependencies. GOS. Default to Linux, the operating system for which to compile Go code. So that's Go OS is what that variable is. Go Arch. I'm guessing it's going to default to AMD 64 and the architecture for the processor, which compiles the Go code. Go Flags. The flags pass to the Go build tool. So similar to Java, Maven, and Gradle, you can pass the Go build and then a whole bunch of other command line flags to help with the Go build. Go Private. A list of glob patterns and prefixes to be fetched from source. Read the Go Private modules documentation for more information. That would probably be just simply a list of glob patterns and prefixes that you're going to go out and actually fetch from source as opposed to just the version that gets reported back from Go. Maybe you have something that has a false positive or something like that and you want to fetch the actual source. Go for it. Specify it right there. Other variables. The previous tables are not an exhaustive list of all the variables that can be used. They contain all the specific GitLab and Analyzer variables we support and test. There are many variables, such as environmental variables, that you can pass in, and they do work. This is a large list, many of which we may be unaware of, and as such is not documented. So what we've read What we've read so far are the list of GitLab supported environmental variables. You might go look at Bundler or one of these other scanning tools and discover on their documentation they have more variables you can pass to it. These are the ones we've read are the ones we are aware of and can help you support. If you see something that you need help with that we don't have listed here as unsupported, please contact us and we'll see if it's something we can help you support. For example, to pass non-GitLab environmental variable HTTPS proxy to all dependency scanning jobs, set it as a CI/CD variable in your GitLab CI YAML file, like that. Look at that. Gradle projects require an additional variable to set up use of a proxy. So beware of that. Gradle, I think, requires 2 or more for fetching items from a proxy. Alternatively, we may use it in specific jobs like dependency scanning. Here's dependency scanning variables, HTTPS proxy, blah. As we have not tested all variables, you may find some do work and others do not. If one does not work and you need it, we suggest submitting a feature request or contributing the code to enable it to be used. So again, we desire you to please reach out to us and submit a feature request. Using a custom SSL certificate authority. You can use the additional CA cert bundle CI/CD variable to configure a custom SSL CA certificate authority. The additional CA cert bundle value should contain the text representation, like that, of the X509 PEM public key certificate. For example, to configure this value in the GitLab pipeline file, use the following. Variables, additional CA cert bundle, colon, and then we just throw a little pipe, and here's all the certificate goodness. Again, used often by big enterprises to import like a on-premise like Windows Active Directory certificate or some other non-public certificate from the public internet, something that's local to your company that nobody else can see but should be trusted. The additional CA cert bundle value can be also configured as a custom variable in the UI, either as a file, which requires the path to be a certificate, or as a variable, which requires the text representation of the certificate. So this just hints that there are other ways in GitLab that you can configure a custom CA certificate if you live in a corporate environment, for example, or enterprise environment that uses CA certs that are not known to the public internet. Using private Maven repositories. If your private Maven repository requires login credentials, you can use the Megan CLI ops CI/CD variable. That's a hint and a suggestion. Please read more on how to use the private Maven repositories. We had read about that CLI variables available. FIPS-enabled images. So, introducing GitLab 1410, GitLab team members can view more information on the confidential issue here. GitLab also offers a FIPS-enabled Red Hat UBI versions of the Gymnasium images. I'm curious. Let's take a look here. Universal base image. Yep. Introducing the Red Hat Universal Base Image. Government and or big enterprise or highly secured enterprise sometimes requires FIPS-enabled versions, and we have this Universal Base Image version of the Gymnasium images for government and other high security type clients to use. Gymnasium scanning jobs automatically use the FIPS-enabled images when FIPS-MOB is enabled in the GitLab instance. And that's an instance-wide setting that your GitLab administrator sets. And those images are automatically enabled. So there you go. To manually switch to FIPS-enabled images without messing with your GitLab instance-wide settings, set the variable DS, dependency scanning image suffix, to -FIPS. Dependency scanning for Gradle projects and auto remediation for Yarn projects are not supported in FIPS mode. Reports, JSON format. The dependency scanning tool emits a JSON report file. For more information, see the schema for this report. Here's an example of a dependency scanning report. This won't surprise you. There's a version number and then a whole bunch of vulnerabilities along with a vulnerability ID hash here. Tells you it was found from dependency scanning. Here's a regular expression denial of service attack, which has the same message. The debug module is vulnerable to regular expression denial of service when untrusted user input is passed. These are the kinds of things that you would see probably like in a CVS, except we bundle it up into a nice JSON report for you. Some of our customers like to use these JSON reports and export them to a third-party tool. There's several other third-party tools that our customers use these reports to then manage their security vulnerabilities in a third-party tool for maybe audit, compliance, or some historical reason. Cyclone DX, software bill of materials. In addition to the JSON report file, the Gymnasium's dependency scanning tool outputs a Cyclone DX software bill of materials, or SBOM, for each supported lock or build file it detects. These Cyclone DX SBOMs, named GL for GitLab, SBOM, package type, package manager, .cdx.json, which is the standard suffix, are saved in the same directory as the detected lock or build files. For example, if your project has the following structure, here's a Ruby project with a gemfile.lock, then the Gymnasium scanner generates the following Cyclone DX SBOMs. There's your Ruby project, gemfile.lock, and there's the Cyclone DX formatted GitLab SBOM gem bundler cdx.json file. Hey, look, another project with a lock file, another SBOM file. Oh, look, a PHP project with a composer.lock file. There's the generated GitLab SBOM packages composer cdx.json file. Hey, look, a Go project. There's the GitLab SBOM Go cdx.json file. You can download Cyclone DX SBOMs the same way as other job artifacts, and that's available in the GitLab web user interface. Merging multiple Cyclone DX SBOMs. You can create a CI/CD job to merge multiple Cyclone DX software bill of materials into a single software bill of material. For example, if you were, say, a customer who is contracting to do work, perhaps a government contractor, and you have to prove to the government that the software you produced is not reliant on third-party packages that are not allowed or outdated or vulnerable, and you need to provide a software bill of materials as proof to the final finished project, here's how you would merge multiple SBOM files into a single file for a legal, contractual, regulatory style need. We're going to skip over reading all this. Versioning and release process. Check out the release process documentation. Contributing to the vulnerability database. If you find, please search the GitLab advisory database, and you can also submit new vulnerabilities. GitLab has a feature where if during, outside of dependency scanning, we have a fuzz testing feature and several other dynamic application security testing features that if you discover vulnerabilities that are not known to the public internet and don't have a CVE or any other known vulnerability number, you can submit them using the GitLab web UI into the GitLab advisory database. And those links there will help you get started on how to submit a found vulnerability in a language or in an application that you've written that has not been discovered by the public internet. Offline environments. Pretty specific use case. We'll read it briefly and then I'll let you read the rest of it on your own. For a self-managed GitLab instance in an offline and limited, restricted, or intermittent access to the external resources through the internet, I'm thinking government or big enterprise, some adjustments are required for dependency scanning jobs to run successfully. For more information, see offline environments. I realize that common industry practice in naming offline, what GitLab calls an offline environment, also called an air-gapped environment, private network or private environment, on-prem with no access to the internet, secured environments. Those are all synonyms for offline environment. So air-gapped, any of those things are all synonyms. The rest of this document talks about how to configure offline dependency scanning, how to host your own registry if you have an air-gapped or offline environment, how to set different dependency scanning jobs, to use local dependency scanning analyzers, various setup things for various languages, how to host your own Gymnasium database advisory database, again for an offline or private or air-gapped environment, using a local clone. All of these things are very specific to specific customer needs. So I'm going to stop reading right there and I'll let you discover on your own for your very specific need just exactly how to set up all of those private offline environment things. Okay, Thank you for sticking with me for what is admittedly a very technical and academic read of a paper, and listening to some of my color commentary as I added from a solutions architect point of view. In the next video, we're off to more setting up GitLab application security testing. We'll do some more hands-on stuff and read some more documentation together.